In this video, we are going to do 24.04 rainfall. All right, so the problem downloaded and opened up in Racket. So let's just read through the problem statement here. Problem A, complete the design of total warm rain that takes a list of weather data and produces the sum total of rain in millimeters on days where the average temperature was greater than 15 degrees Celsius. The function that you design must make at least one call to built-in abstract functions, so map, filter, fold, build list, etc. There is a very nice solution that composes calls to just 3 built-in abstract functions. So if you have struggles with this, just don't do the abstract functions first. Just write things in the classic recursive template way first and then abstract later. In fact, that's what I'm going to do to show my reasoning. All right. So they give us an example here. Before we go through the example, let's just read through the data definition here. So we have a weather. This is weather data. And the first field is the date. The second field is the max temperature in Celsius. Next is average temperature, so it's this field here. Next is min temperature, and then the rainfall, and then the snow, and then the precipitation. And you can read the interpretation here if needed. All right, so they give us an example here. So let's just go through that. So the example says total rain consumes this list of weather data, and it should produce this. Why should it produce this? Well, let's just read through this problem statement again. So it's, let's see, produces the sum total of rainfall in millimeters on days where the average temperature was greater than 15 degrees Celsius. So this over here, the second field, is the average temperature, right? The first one was the max temperature. There's a lot of information here that you need to ignore, right? So that's the key to this problem, right? So this is the average temperature. It's the third field because 1, 2, 3. So 1, 2, 3. So we're going to grab the ones that are greater than 15 degrees Celsius. So 17.7 is greater than 15 degrees Celsius, 15.6 also is, and then 13.7 also is not. So only these two. We only want to do something with these two, right? We want to sum up the total rainfall in millimeters on days where the average temperature was greater than 15 degrees. All right, so we have the days where the temperatures were greater than 15 degrees. Now we need to add up the total rainfall. That's these two, 0.2 and 0.4, and we get 0.6, right? So it's this field, right? The third to last, right, is the rainfall one, right? So with that out of the way, they give us the signature. Total warm rain consumes a list of weather, produces a number, produces the total rainfall in millimeters on days with greater than 15 degrees Celsius average temperature. And here's the stub. All right, so pause the video and try to work through this on your own. I'm looking for spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. All right, so what we need to do is to write the examples next, right? So check expect total warm rain of the empty list, right? So it should produce 0 because there are no weather data, right? Let's do the example that they gave us here, right? So calling this check expect, gonna hit Control I to indent, produces this 0.6, but we can be sort of more clear here by saying it's just the addition of 0.2 from here and 0.4 from here, all right? And you can do another example if you want, but for the sake of time, I'm just not going to do it. All right. So these are good enough tests. Just run against the stub here. We get mismatches, right? 0.6 differs from 0, and 0 differs 0 passing, but that's because we just spit it back out. All right. So signature purpose stub. All right. Let's do the template next. All right. So since this consumes a list of weather data, let's just do the classic old recursive template first, right? So we do something when the list is empty, right? And then otherwise we do something with the first of the list and then the recursion over the rest of the list. All right. All right. Let's see, getting some errors here. Else. Con extended clause with question and answer, but only found 3 parts. 1, 2. Oh, all right. I have to wrap this around dots or else it's going to yell at me. Control I to indent. All right. So hopefully this gives you a little more hint as to how to approach total rain. So now really pause the video. Hopefully this should be all the mental scaffolding needed to solve the problem. I'm going over spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So given an empty list, produce 0. So that is the base case. All right. So next is the hardest part, right? Produce the total rainfall in millimeters of days with greater than 15 degrees Celsius average temperature. So we're going to be given a huge list of weather data, right? And we only want to include the ones that are 15 degrees Celsius or above, right? And this is the one we exclude. So sometimes we include something, sometimes we don't include it. That sounds like some decision making is going on in here. So that indicates we need an if over here, right? So what is the condition? Well, it's when the days with greater than 15 degrees Celsius average temp, right? So when the weather data, list of weather, has an average temp of greater than 15 degrees Celsius. So we need to grab weather. It's called average temp, right? So just like here in the problem statement, right? So the sum total rainfall on the days where the average temperature was greater than 15 degrees temperature, right? So that's the key here, right? Average temp. All right, so average temp is greater than 15 degrees Celsius. All right, so we do want to do something in that case, right? In that true branch and then something else in the false branch, right? So what we want to do is let's just take the first, just make a list first, right? It's gonna be wrong, but we're gonna get closer to the solution, right? Because this hopefully should be ringing some bells, right? This looks like a filter, right? If you look at all the problems that we've done with the filter or keep if, right? We're consing the first of the list onto the recursion of the rest of the list. And this is where we exclude elements. If we run it, we should be producing, let's see, getting an error here. Must be a list. Second argument must be a list, but, oh yeah, okay, it's because we're producing 0 here for this base case. All right, whoops. Okay, now we're getting more of what I expect, all right? So this, right, it differs from 0.6, but it has the two things we want to sum together, right? It's these two, it has this. So we're building the list correctly, right? We're excluding this part, and we have these two elements. So let's just turn it back to what it was before. And we want to add, right, this is gonna be weather data. We want to add the rainfall. So it's gonna be weather dash rain over here to get the rainfall out. All right. And then of course we sum it together and then assume the recursion works for each other weather, right? So you run this code, both has to pass. And that is how you write it with a recursive style template, right? So sometimes it takes writing this first before you go to the abstraction, right? Even though the problem statement says, hey, you must use at least one call to a built-in abstraction function, you don't have to do this from the get-go, right? Sometimes it takes writing it more verbosely with the things that you're already used to, right? You're probably much more used to writing this cond recursion template rather than thinking in terms of map, filter, fold, and etc., right? That's going to take a little more practice, but nonetheless, right? This gets us a step there because as we type this out, we realize this looks a lot like filter, right? We do something and we keep it based on some criteria, right? This was cons. And then we, on this criteria, this is the false branch. We don't include that number, right? We don't include this one, right? So that gets us a little bit closer. So now let's actually try to implement this using the built-in functions, right? So we just figured out that this is going to use filter because this looks a lot like filter, right? If, and then some condition, keep something and then throw away something, right? By recursing it over without doing any operation here, right? So we need a filter here, right? That's just filter. So define their total warm rain v2. All right, we're going to filter. We need a local function because filter takes in 3 arguments, right? 2 arguments. A function that takes in an x and reduces boolean and then the list of x, right? So we're going to need local here actually. All right. And then we're going to put the filter inside the local. All right. All right. the filter is just going to filter through the incoming list. All right, and then the function is going to be a function that filters out the greater than 15 degrees average temp, right? So we're going to say greater than 15C question mark, right? So we're going to define this function here, greater than 15C question mark, that consumes a, let's see, weather. So it's going to be, we'll call it WT, and this is of type weather. So let me just write down the types here because it'll help. So 15C, greater than 15C question mark, consumes a weather and produces a Boolean, right? Because filter has to take a function that produces a Boolean. And this X is going to be the same type as the list of X. And of course, the list of X is going to be list of weather, right? That's what's being passed in to total warm weather. So filter is going to call greater than 15C with a weather, right? And we have to turn this into a Boolean. And the answer is here, right? So it's going to pass us the weather. We don't have to take the first of the list, right? Filter is going to pass us the first of the list. So we don't have to write that. So since this is of type weather, we got to take the average of it, the weather average temp of it. All right. And then we're going to add greater than 15. All right. So TMP, not TEMP. Okay. So greater than 15. All right. And then we run this code, right? We have to, I'm going to comment out this old one because it's not running. I got to rename this v2, right? We're back to where we were before, right? We have the two that we want that we need to sum up. And then this one gets excluded because the filter is working, right? The filter is excluding this element. We only want to sum up the rain for these two elements. All right, so we're gradually getting there. So filter is done. Next, what do we want to do, right? We have the list we want. We have these two items we want. We want to get the rain out of there, right? Not the rain. The rain, this number, right? 0.2 and 0.4, and then add them together, right? So what we need is map, right? We have a list of weather, right? And then we want to turn that into we want to get the individual, one of these pieces out. So weather dash, so we need to wrap this around a map, which takes in a function, and then it's going to be fed in the filtered list, right? So to get the weather rain out, right, use this weather dash rain. All right. So I hit run, and now we're very close, right? We hit the list 0.2, 0.4, and you have to produce 0.6. So that means we're at the final stage now. All we got to do is add it up together, right? We have the list of these two numbers. We're going to add those to get 0.6, which is what our test expects. All right. So that is, right, we can approach this by, doing the recursive template, or we can recognize, right, writing a recursive template over a list here, or we can recognize that it is a fold, right? So fold, just make sure I'm wrapping this correctly. Fold L plus is the operation, 0 is the base case, and then over this list, right? It's going to be fed into the map weather rain of filter greater than 15C WLST. Run this code, and both tests do pass. So this version uses 3, 1, fold L, 2, map, and 3, filter. Uses 3 built-in abstract functions to accomplish this goal. And it's a little more elegant, right? Kind of reads more nicely, right? We filter the weather data, the weather average temperature that's greater than 15 degrees Celsius. We get the weather rainfall out of them, and then we sum them all up together, right? So 1, 2, 3 easy steps, right? And it's kind of a bit more readable than what we did with our recursive template here, right? Recursive template, it makes sense, right? We take an if, and then we make sure it's greater than 15 degrees, and then we add getting the rain out of each one individually, and then doing the recursion here, right? Either one is fine, but this one, again, it's just 1, 2, 3. I do a filter, I do a map, and then a fold, right? So arguably this one is easier to conceptualize when you get more experience, but this one might be easier to write if you're just starting off for the first time, right? It takes a little while to think of problems in filter, map, and fold. But nonetheless, right, the problem statement here says you needed to use at least one. So you can use, filter and map and then write the recursive template. And then that's one other solution. You can filter first and then write a recursive template over this filter, and then like so. But nonetheless, right, this is the final answer. This is the most optimal answer. There are two other answers that I can think of. But nonetheless, right, I recommend you submit this to Hand-In and then check your score. And then, yeah, make sure it passes the greater side tests. So initially, we started this problem off with this really, really big data definition that had 1, 2, 3, 4, 5, 6, 7 fields. Weather has 7 fields, but only 2 of them were relevant to the problem statement here, right? Average temp and rain. All these other ones, right? All these other 5 other ones were not relevant. So this problem really stress tests your ability to ignore irrelevant pieces of information that come along for the ride, right? Like snow, precipitation, max temp, and the date, and etc. Right? And this is often going to be the case for our future problems going ahead, right? Beyond that, though, if you want more practice with built-in abstract functions and using local, right? We have to use local here. I recommend you go to the website and pick any of the 18.0 problems and try to use map, filter, and fold with local, because some of these will require local to write these functions, right? In fact, I'm going to do one of them. I'm going to do employees, right? So I recommend you go to the website, right? If you already have the solution file, you can use that, or you can download the solution file here, right? So I'm just going to pick that. So employees, right? I got to change the language level, right? So to #lang HTTP/ISL plus, right? Start referring the racket language with the #lang instead, right? Because you're going to get this thing on the top right, which you can lock and unlock. So if you hover over anything, it'll just tell you what it is, right? And a lot more features like default arrows and etc., which I explained before, right? So let's just do this one, right? There's not going to be a checker for this, right? No grader. So if it passes the test, then you should be fine, right? So let's just rewrite this in terms of one of our map, filter, and fold. So pause the video and try to work. We're going to rework this 18.0 file, right? We're going to do raise wages. I'm going to leave the rest to you, right? Try to rewrite raise wages in terms of map, filter, or fold, all right? I'm going to go for spoilers in 3, 2, and 1. All right, I'm assuming that you guys took a good swing at it. So now let's go over it together. So raise wages consumes a list of employee, a number, and then produces a list of employee. Increases the wage of all given employees by the given raise. So this second argument is the given raise. This is the list of employees. We're going from a list of employee to another list of employee. It doesn't look like there's an if here, so we're not doing a filter, right? It looks like we're just doing a map, right? We're just raising the wages of every employee, and upwage is a helper function that is provided for us. So that makes it a lot easier. So let's just rewrite raise wages in terms of map, filter, and fold, right? So this is a map, right? We're going from a list of employee to a list of employee. We're not reducing the amount of employees, right? And yeah, that indicates it's a map. So to raise wages, it's gonna have the same arguments. So the employee list and the raise. And we know that this is just a map, right? And map takes 2 arguments, and we can see here, we hover over map, right? Gonna lock this. Takes in a function that consumes x and produces a z, and then the list of x is going to be the x input to this function, right? So this is going to be the employee list. All right. So we need to raise all the wages, right, of all the employees. So we're going to need a local here, and then we're going to need some definitions, and then we're going to put the map inside the local, like so. All right. So what do we want to do with all the employees right over here? Well, we want to raise their wages, right? And there's a function upWage that does this. So upWage. But there's a problem. UpWage takes in 2 arguments, right? But map can only consume a function that takes in 1 argument, except that it was given another list. But let's just ignore that, right? It can only take 1 argument. So we need to define an upWage over here. We're just going to copy and paste it, right? And just remove the raise over here, right? So instead of this argument here, we're going to copy and paste this function, stick it in here, and hit Control-I, and then I'm going to copy and paste the signature. All right, I'm going to show you what happens if we just run this, right? It's going to give us an error, right? This error here, right? It's going to say map map first argument must be a function that expects one argument, right? So again, upweight has 2 arguments, but we can just delete this and have the mechanism of functions looking up their variables that they don't have up, right? So yeah, instead of raise being a parameter here, we're saying, hey, functions naturally look up, right? Look outside themselves and just look up and you'll see raise from the outer function of this local block, and just use that instead. And that will turn this into a function that map can accept, right? Well, 1 argument function. Upweight is now 1 argument function, so we don't need this number. Run this code and all 9 tests pass, all right? So there are a lot of other problems here, right? You can use filter and map fold for all these other problems. And yeah, for all the 18.0 problems, right? Possibly 19, 19.01. And yeah, you can use map, filter, and fold. And I recommend you guys do this to really get practice with map, filter, and fold if you're not comfortable and you really want to get your brain trained into thinking in terms of map, filter, and fold. But anywho, that is about it for this rainfall video problem, and I'll catch you in the next one.